Assalamualaikum. Now I would like to share with you how to apply polar coordinate of plane. Okay, if you see in your textbook, we have three types of polar coordinate of plane, polar coordinate of cylinder, and also polar coordinate of sphere. So this is polar coordinate of plane, where you can see the x, y, the Cartesian coordinate, Cartesian coordinate of x, y will be represented in polar coordinate of r and theta. Okay, so this polar coordinate specifically will be used to do the surface integral ds. So it will be respect to r dr d theta. The integration form will be in terms of r dr d theta. So of course, when we talk about polar coordinate of plane, the only one, not the only one, this one, the polar coordinate is particularly to solve the circle and also the parabolic. So let us see, this is a circle where you know that the general equation of the circle is x squared plus y squared equal to r squared. This is general form of general equation of a circle, where the radius is from the origin to the circumference. Okay, so the radius, the r, so the r here will be replaced by this value. Let's say you have x squared plus y squared equal to 9, therefore radius is equal to 3. Okay, then one more thing is the angle of the circle. You can see this is a full circle, so the angle is 0 to 2 pi. Very easy. Alright, how about if you have half circle like this? Half circle, so radius is straightforward from the equation of x squared plus y squared equal to r squared. Okay, and then the angle is from the 0 to pi. Okay, so angle is 0 to pi. And then if you have first octant circle like this, so the radius as usual from the x squared plus y squared equal to r squared, and then the theta is obviously from this to this, so it is 0 to pi over 2. Okay, so let's say you want to solve the double integral. You want to know the surface integral of this first octant circle. Okay, so what you have to do is, let's say you want to solve the function f. Okay, so make sure the f will be in terms of r and theta. Okay, so you substitute. So you have here, uh, r dr d theta. So radius is 0. Let's say your equation is x squared. For example, you have so radius is 0 to r. Okay, let's say your equation is 0 is x squared plus y squared equal to 9. So radius is 3, so 0 to 3. You don't have to substitute the r here because we have dr. You're going to integrate r after this, so make r as a constant in this case. So theta is 0 to pi over 2. Okay, very easy. Alright, next. So polar coordinate of plane also can be used to solve the paraboloid. If you have to solve the surface integral for paraboloid, you can use polar coordinate of plane. Why? Why? Because if you have to convert the paraboloid into dimension. You view this paraboloid from the above. You imagine your eyes is here. You see the parabola in 2 dimension. This is the equation of this is the surface of paraboloid. Okay, this is the equation, or this is the equation of parabolic. This is the surface that you want to solve. Okay, so you can see this parabola in 2 dimension just as a circle. You agree with me? If you see from the 2 dimension, from z axis, you just can see this surface is just a circle. So a circle, as we know previously, I told you that you have to use polar coordinate of plane. Okay, alright. So for parabola, we have to use polar coordinate of plane. Alright. Now we have two types of paraboloid. The first one is represented by the equation 4z equal to x squared plus y squared. X squared plus y squared, you can see positive x squared plus y squared. Positive x squared y squared. If you sketch x squared plus y squared, x squared plus y squared. Sorry, if you sketch, sorry, my mistake. Okay, if you sketch the equation of 4z equal to y squared. Okay, 4z equal to y squared or y squared equal to 4z in two dimension. Y squared is positive quadratic, positive 4z. So it will be positive quadratic. So when you transform in three dimension, it will be positive as well. Okay, so that's why if you want to recognize which parabolic that you have to use, so you see if it is positive, so it will be in positive side like this. Okay, if the second one you have negative x squared minus y squared, so it will be in negative quadratic. Okay, so now how to determine the radius for both paraboloid? Okay, so let me talk the first one. The first one, we have 4z equal to x squared plus y squared, and also you have the equation z equal to 2. This is z equal to 2. Z equal to 2. So this parabola is located below the z equal to 2. So how to determine the radius is you substitute z into this equation. So what you have is you have x squared plus y squared equal to 8. So means that the radius is square root of 8. Okay, and the angle is very straightforward because this is a full circle, full parabola. So it is 0 to 2 pi. So if you want to do the surface integral, okay, r d theta dz dr r d theta dr. Okay, so r is 0 to square theta is 0 to 2 pi. So r is 0 to square root of 8. How about the second one? The same thing. If you want to know the radius, you have now z equal to 4 minus x squared minus y squared, and also z equal to 0 means that z equal to 4 minus x squared minus y squared is above the z equal to 0. This is z equal to 0. So you substitute z equal to 0 in this equation. So you will have x squared plus y squared equal to 4. You agree with me? Therefore, radius is 2. Okay? And then the angle obviously is 0 to 2 pi because it is a full paraboloid. Okay? So that's all for polar coordinate of paraboloid. Inshallah, when you do exercise, it will be more clear for you. Thank you. Assalamualaikum.